And welcome back to Lesson 3 of Unit 2 on slope. A couple of things we'll be doing in this lesson. We'll be calculating the slope of a line using the slope formula. We will also be determining whether lines are parallel, perpendicular, or neither, and we'll be writing equations of those lines, whether they're parallel, perpendicular, vertical, or horizontal. So first off, let's start off with a little review of what slope is. And the slope of a line just refers to the ratio of the vertical change in the top over vertical change y over the horizontal change x. It's the rise over the run, and it's any 2 points. You can choose any 2 points to calculate the slope of a line. So the formula for calculating slope is y2 minus y1 over x2 minus x1. Basically, all this is doing is finding a vertical change here, how much y is changing, divided by how much x is changing in a horizontal direction. So let's look at what that looks like in practical matters. We have a question here that says find the slope of a line that passes through these 2 points. So again, we want to just choose the change in the y variables. It doesn't matter which one you choose first, whether this is y1 or y2. I just chose 3 first. So 3 minus a negative 1. So you're going to want to set up parentheses when you have a lot of negatives here. If I start with 3 on the top, I must start with negative 5 on the bottom. So if I start with this coordinate first, I have to start with this coordinate first. And that says negative 5 minus a positive 2. So 3 minus a minus 1 is a 3 plus 1. That gives us a 4 over negative 7, which is a negative 4/7 slope. Vertical and horizontal lines. The equation of a vertical line is given as x equals c. So it's just x equal to a number. C is a constant. The slope of a vertical line is undefined. Okay, vertical lines have an undefined slope. The equation of a horizontal line is given as y equals a number, y equals a constant, where the slope of a horizontal line is 0. So you will need to know those 2 facts right there. You'll see those appear over and over again. Vertical line is an undefined slope, and I want you to say undefined, not no slope. I want you to say undefined slope. And a horizontal line has a 0 slope. So if the line rises to the right, this is an example of a positive slope. And if it rises, if it's horizontal, that's an example of a 0 slope. If it falls to the right, that's an example of a negative slope. And if it's vertical, that's an example of an undefined slope. Parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Or another way of thinking about perpendicular lines, the product of their slopes is always 1. Okay? Or is it negative 1? I have to think about that. The product should be negative 1, excuse me. So they're opposite reciprocals. So they have the opposite sign and they're flipped over. So here's an example for you of a couple of lines that are parallel. So we have y equals x plus 5, and y equals x minus 3. The slope on all 3 of these lines is 1. The only thing that's changing is where they cross the y-axis or the y-intercept. So those are parallel lines. Here's an example of perpendicular lines. We have y equals 3x and y equals negative 1/3 x. These are opposite reciprocals, 3 and then negative 1/3. And if we multiplied those together, we would get negative 1. So the product of their slopes is negative 1. All right, let's do some examples together. It says graph the line through the point negative 2, 4, and we want it to be parallel to the line that has this equation. Well, if it's parallel, we need to know what the slope is. So that's the first order of work we need to do here is figure out what that slope is. So if we want to know the slope, we need to solve it for y. We need to get y alone. We want to put it in y equals mx plus b form, and then whatever number is in front of x is the slope, right? So that's our goal. So let's go ahead and take a look at that. So I'm going to subtract x from both sides, minus x and minus x. Then we have negative 3y, so don't forget that negative sign, is equal to, I want the x term first, negative x plus 3, and then I'm going to divide every term by negative 3, right? Negative 3 and negative 3. So that gives us negative 3 divided by negative 3 cancels out, and we get y equals. Now these have two negatives, so those are going to cancel out, and I'm going to have an x term. And I basically have a positive 1/3, right? It's one way I could write that. And then this plus a minus thing right here, plus 3 over negative 3. This number right here would give me a negative 1. So I'm just going to write that as minus 1. That means the same thing. So my slope is 1/3, right? So the thing I needed to know is m is equal to 1/3. So in order to write that equation, let's go ahead and do that. We know that the slope is 1/3 now. If I want to write the equation, graph the line through negative 2, 4 that's parallel to the line with that equation. I don't have to write the equation, I just needed the slope. So let's go ahead and figure out the slope then. If it's a 1/3, we can start with the point that we had right here. If the slope is 1/3, that says I can go up 1 and right 3. Okay, so the thing I want you to notice about this, this is positive, which means up, and this one's positive, which is to the right, right? This is an up, down, and this is a left, right. So I can do that as many times as I want. I can go up 1 and right 3, up 1 and right 3, and keep doing that, and that would give us a picture of what our line looks like. So the opposite thing to do is we could go down 1 and left 3, would be the same thing, and that's how we get the rest of the graph. You could also think of this slope as negative 1 over negative 3, which is down 1 and left 3, right? So this is a negative direction for each of those, and a negative over negative is positive, so that's how we get the other side of our graph. So that is what our line would look like, and I'm not sure, I don't think I have that one disappearing on us, so that's what that would look like if we were to draw the line. Let's see if I can give you a good picture in here. Go ahead and draw that in there for you. Something like that, right? So that's what our line would look like. Here's another one. It says graph the line through that point that's perpendicular to the line that has that equation. Well, we still have to find what the slope is so that we can figure out what our slope of our perpendicular line would be. So again, we need to solve for y. So I want to subtract 3x from both sides, and then we'll solve it for y. So I'm going to go minus 3x, minus 3x. So remember, we're doing y equals mx plus b, slope-intercept form. So when I go ahead and subtract 3x, those are gone. I have a negative 2y is equal to a negative 3x plus 6, and then dividing every term by a negative 2. So watch your signs in here when you're doing your division. This gives me y equals, now negative 3 over negative 2 is a positive, so I have 3 over 2 times x, and a positive over a negative is a negative, and 6 divided by 2 is 3. So this tells me the slope of the line, slope of this line here, but the line that I want will have an opposite reciprocal. So the slope that I want, I'll put this in a different color, the slope of the perpendicular line, I'll write it this way, that means perpendicular. We got to flip that over, so we get 2 over 3 instead of 3 over 2, and it's the opposite sign. So we want it to have a negative 2/3 slope. So that says, if we want to graph that thing, we can go down 2 and then right 3, or we could put the negative down below. We could think of a slope of the perpendicular as 2 over negative 3. It doesn't matter where you put that negative, so then this one would be up 2 and left 3. Either way will give us the correct slope. So I've graphed our point right here, negative 6, 2. Then I'm going to go, let's see, I'll just go down 2 and then right 3. 1, 2, 3. There's a spot right there. Or I could go up 2, like I told you before, and left 3. 1, 2, 3. So our line would look something like that, and I'll go ahead and draw that in there for you. So our line would look like something like that, right? And there you have it. All right, I've got a whole bunch of problems for you here. I think there's 8 or 9 problems on the next few slides. I've explained all of the content here, so just go ahead and do these on your own and bring those answers to class. Looks like we have 12 problems, so go ahead and do those and bring your answers to class, and we'll see you next time.